Okay, so here we have the review for the Chapter 11 quiz, or the first 4 sections. So we're trying to find the measure of an arc, right here, right? We have the arc length. Remember, measure is a degree measurement. Measure of the arc is degrees, okay? So the formula is the arc length is equal to the arc measure, which we don't know, divided by 360. Remember, this fraction is always just a percentage of, this divided by 360. It's just a fraction, right? Times the circumference, which is 2 times pi times the radius, which in this case is 7. All right? So basically, we're trying to get x by itself. So I'm going to calculate this first. 2 times pi times 7. And remember, you can use the pi key or 3.14. It doesn't matter. So if you do 2 times pi times 7, all right, you get 43.98. So since this is 43.98, I'm going to write it above because I don't have a lot of room. I'm going to divide both sides by 43.98. Okay, so 13.7 divided by 43.98, and I get 0.3115. I'm going to leave it like that. There's not a lot of room, so I'm going to come up here. Apologize for the room. So what we have is 0.3115 is equal to x over 360. So to get x by itself, I just need to multiply both sides by 360. When I do that, I get 112.14, so approximately 112 degrees, just rounded. Now again, it's going to be slightly off based on whether you use pi or 3.14 or where you round, but you end up with around 112 degrees. There'll be some leeway in grading when you take the quiz. Don't worry about it. Okay? So number 2, arc length of QS. All right, so this time we do know the measure of the arc. Okay, so we do 83 over 360 times 2 pi radius. And remember, that was the same thing we did over here, except before we didn't know the arc length. I'm sorry, the measure of the arc, but we knew the arc length. Here we don't know the arc length. This is our unknown over here. So if we just calculate the right side, number crunch it, we're good to go. So all we have to do is type in 83 divided by 360 and just keep going. That's 0.2305 repeating. And then just multiply times 2 times the pi key or 3.14 and times 4. You just keep going. So the answer ends up being 5.79. And all I did was type this into the calculator, just how I see it. 83 divided by 360 times 2 times pi, or 3.14, times 4. That's it. Okay, circumference. Remember, the circumference is really just 2 pi r. And you remember me at the beginning saying that 2 pi r is part of that formula right there? Okay, so we know the arc length is 8, and that's going to be equal to 48 over 360 times 2 pi r, which we could just say circumference, because 2 pi r is the circumference. So if we just do 48 divided by 360, we get 8 equals 0.13 repeating times c, the circumference. And then we just divide by 0.13 repeating. And when you're doing something like this, you want to put in a bunch of 3's in the calculator just to get the most accurate number. So 8 divided by 0.13 Just a bunch, a bunch of them. And you get about 60. That's the circumference. It's technically like 59.97 something, but that's good enough. Okay? Now, we could have done it a different way. We could have had 2 pi r here instead. And then we would have just done 48 divided by 360 times 2 times pi, gotten a decimal, and divided by that. That would have given us our radius. And then we'd have to, well, then multiply by pi and 2 again. It's just redundant. There's no reason to do that. If we are trying to find a circumference, the quickest way is just put in C there, with 2 simple division problems, and you're there. All right, convert 26 degrees to radians. So all we do is we take 26 times, I don't know why I put an X there, we don't do that in high school, times pi over 180. So basically that's just 26 pi over 180. And then we reduce 26 over 180 and find out that they're both even. So that's 13 pi over 90. And it won't go any further. So that's reduced. That's a 1 right there. That's a horrible 1, so we're just going to do this. We'll start over. 1, 3 pi. And if you just wrote as a fraction 13/90ths pi, like this, that would be fine. That works also. It's up to you. All right, now going the other way. We have 5 pi over 9. So we're going to do 180 over pi. Just go in the opposite direction. The pi's cancel. Okay? We have 5 times 180 divided by 9. Or if you think about it, simplify, this goes into this 20 times. So 5 times 20 is 100 degrees. Now again, you could have done 5 times 180 and gotten 900. And then 900 divided by 9 would have given you 9. Sorry, 900 divided by 9 would have given you 100. So you can go either way. It's up to you. All right. Now on yours, it's hard to tell. This is the red. This is the blue. It doesn't really matter because you're finding both of them. Okay. So the area of the red sector is simple. You're going to have the formula on the test. All these formulas will be on there. You take the fraction that we know, so 100 over 360, because we're finding this right now, times pi r squared. Remember, this right here is the area of the whole circle, but we're just trying to find this fraction of the circle. So you just do the math. Okay, now since we know the radius is 12, we just stick that in there. And now all we do is crunch the numbers. So we do 12 squared, which is 144. I'm going to do 144 times 100 divided by 360. And we get 40. So the answer is 40 pi. And all I did was crunch the numbers. I did this first, times 100 divided by 360. Okay? Or I would also accept the answer, approximately 125.7. That was with using the pi key. If I use 3.14, I get 125.6. And I would accept either answer. So if we know that's 100 and there's 360 in the entire circle, that means this is 260. Right? So we're going to do the exact same problem. 260 divided by 360. Now, I don't know why I wrote equals. Times pi, again, 12 squared. So 144 times 260 divided by 360. And I end up with 104 pi. or approximately 326.7. And that would be square yards. Okay? All right, in the diagram, RSTUVWXY. Okay? It's a regular octagon inscribed in circle C. What is the center? Well, the center is just a weird line. Let's try that again. Okay, my computer is just possessed right now. Let's try this one more time. C. There we go. C is the center. What is the radius? Okay, well, there's a little bit of math to do there. But what is the radius? We're just going to say, name it. So we could say CY or CR. What's an apothem? Okay, the apothem is the line that doesn't go to the circle. It goes to that little triangle there. Okay, it goes to the middle of the line of the chord RY. So that'd be CZ. What's a central angle? Remember, a central angle has the vertex on the center. So RCY or YCR. Totally missed that, didn't I? Okay. Now, find the measure of the angles. Right? RCY. Well, we have an octagon. There's 360 degrees in an octagon. If we divide by 8, we get 45. That means every central angle is 45. So RCY, being a central angle, is 45 degrees. Okay? RCZ, where's that? R to the C to the Z. Well, the apothem is a perpendicular bisector and an angle bisector. So basically it is cutting RCY in half, which makes this 22.5. And then it's asking for ZRC, Z to the R to the C. That's this angle right here. Well, we know that this angle right here is 22.5. We know this and this are both 90. So if we add 90 plus 22.5, we get 112.5. And 180 minus 112.5, because there's 180 degrees in a triangle, gives us 67.5. Now, it tells us the radius of the circle is 8. So we have an 8 right here. Find the area of the octagon. Well, remember, area is 1/2 the apothem times the perimeter. So we have a little bit of work to do here. I'm going to clean this up. This is one of those problems that's not hard. It just takes a lot of steps. Okay? So we're going to do a little trigonometry, and like I like to do, I'm going to take this triangle out, okay, and make it a little bit bigger. Now we have 90 here. This is 8. We've said that this angle here is 22.5 degrees. All right? So we need to find this right here. Okay? So this is my opposite. Sorry, my bad. That's my hypotenuse. And from 22.5, x is my opposite. So opposite over hypotenuse. So I'm going to do sine. Sine of the angle equals the opposite, this is the easy one, over 8. So all I'm going to do is multiply both sides by 8. When I do that, x is going to be equal to sine of 22.5 times 8, which is 3.06. Now remember, that's just this piece right here, which means that this line right here is 3.06 doubled, which is 6.12. So each of these pieces, each of these pieces, the edges of the octagon, I'm not going to go all the way around, are all 6.12. So the perimeter, so let's just write that just to be on the safe side. So RY is 6.12. And the perimeter is going to be 6.12 times 8, which is 48.96. So we're almost there. We have our perimeter. We need to find our apothem. What's our apothem? Remember, it's ZC. That's this right here. Okay? So we have two choices. Since we know this is 3.06, we can either use trigonometry and say the cosine of 22.5 is equal to adjacent over hypotenuse, and multiply both sides by 8 again. Okay? Or we could say 3.06 squared plus b squared or y squared, whatever, equals 8 squared. We could use Pythagorean theorem because we have a right triangle, we have one leg, and we have the hypotenuse. Either way, you're going to get 7.39. That's the apothem. So, back to the original formula. 1/2, or 0.5, times 7.39 times, I had it, where'd it go? 48.96. Oh, there it is. Right above me. So, 48.96 times 7.39, and you could either multiply by 1/2, multiply by 0.5, or divide by 2. Doesn't matter. Hold on, I did something wrong. 48.96 times, I put minus 7.39 divided by 2. And you get, the area is 180.9 units squared. I got 0.91 if you wanted, but it doesn't really matter. So there you go. All right, tell whether this solid is a polyhedron or not. This is a no. No curves. Okay? This one is yes. Let's see what we got in the bottom. 1, 2, 3, 4, 5, 6, 7, 8. So it's an octagonal pyramid. It says, if it is, name it. So it's a pyramid because it's coming up to a point, and it has a base of 8 sides. Here we have yes. 1, 2, 3, 4, 5. That's a pentagon. Pentagonal prism. Because it has 2 faces, 2 pentagons. One here, top and bottom. Okay? So prisms have 2 bases. Pyramids come to a point. One base, come to a point. All right, let's say we're going to rotate this around. Okay, what would it look like? Well, we would have a little cylinder here that would have a radius of 3 attached to a larger cylinder. You can see I gave up a career in art with a radius of 6. This is 7. And this is 10. And that's what it would look like. Kind of like a water jug, like you see at water coolers. It kind of look like that. Number 14. The two congruent circles just fit into the blue circle. Okay? What's the area of the blue region? Well, let's think about this. This 3 is the radius. Well, could it also go here? And couldn't it also go here if it was straight? And wouldn't that mean that this is 3 and this is 3? Which means the diameter of this circle is 3, 6, 9, 12. So we're going to do the area of the big circle minus the area of the little circle. Technically minus the area of the little circle, or just 2 times the little circle. So what is the area of the big circle? Well, it's pi times diameter. Okay? Sorry, area. My bad, I think it's circumference. It's pi r squared. So pi times 6 squared. Okay? And then the area of the 2 smaller circles, which is pi times 3 squared. Well, what that gives us is 36 pi minus 3 squared is 9 times 2 is 18 pi, which is 18 pi. And that's a perfectly acceptable answer. Or you can multiply it out and get 56.6, 55, whatever, okay, meters squared. So a couple of different ways to go about that. Okay? Almost there. Let's do this a little bit, give us some room. All right, find the area of each rhombus tile. Well, very simple formula here. The area of a rhombus is 1/2 the 2 diagonals. So let's just make that a big A. Board tries to screw up on me, I just adjust. All right, it's 1/2, 11.4 times 15.7. Okay. So that is 89.49 millimeters squared. All right. And then the other one is going to be area equals 1/2 again, or 0.5, or divide by 2, doesn't matter. 6 times 18.5. Just the 2 diagonals. Okay, and that gives us 55.5 millimeters squared. Easy enough. But then it says find the area of the entire pattern. So now we got to count. How many of these yellow ones are there? All right, so it'd be easy just to mark them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Looks like there's 32 of these. And how many red ones are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 it looks like. Let me just double check there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It's 21, sorry. Times 21. So this has a grand total of 2,863.68 millimeters squared. This has 1165.5. And if you combine them together, you get 4,029.18. Probably one of the easiest problems on there. It just takes a little bit of time to do both of them, count, and then find the total. But that's it.